Hey, Tim DeStasio here, and I'm in my garage. Don't mind the mess behind me. We've got a bunch of closet organization stuff from IKEA that we're going to be putting together soon, but we're not talking about that. We're talking about the brand new dehumidifier from Santa Fe. This is a 155 pint. Now, this is a brand new model and design, and I've been sent this model in early production to test it. So by the time that you're seeing this video, this model is now out for purchase, but I got an early release of it. And that was really nice of Santa Fe, and I've got a whole bunch of sensors hooked up to it. We're going to be gathering a lot of data, but I want to show you some details about this dehumidifier that really impressed me. One of the main challenges with dehumidifiers, where the rubber meets the road for it to pull moisture out of the air, we need that to happen in the evaporator coil. And the nice thing about a dehumidifier is that it has an evaporator coil, then it has a condenser coil after to reheat that air. But the challenge is we ask a lot of the dehumidifier. Not only do we need to first cool the air down to the temperature where it can start condensating water out of the air, but then we also need to leave enough room in the evaporator to not flood back refrigerant to the compressor and cause mechanical damage. So really, when you think about it, when it comes to an indoor coil on a dehumidifier, we're asking it to do three things. First, cool the air, then pull a bunch of moisture out of the air. Three, to save a little room in the evaporator for some superheat so that we don't cause mechanical damage to the compressor. That is a tall order. That requires that coil to be really big. And in the past, larger capacity dehumidifiers were huge. The 155 and 205 pint model from Santa Fe were almost the size of like a heat pump air handler. But if you notice, this is a really compact design, and that's because they've got some new technology, which really, I think, bends the rules of physics in a way. And what we're going to do is we're going to open up the panels here. I'm going to show you the guts of this dehumidifier. We're going to talk about a few other features, though, first. Now, again, this is an early release model, so the final production will be a little bit more refined. But what I do like about this is that we've got a MERV 13 filter. The little filter door is magnetic, and that's something that they and other models have had. But a 2-inch MERV 13 filter. It also has the ability to be a ventilating dehumidifier. Now, where this is going is in a commercial building. We're not going to be using it as a ventilating dehumidifier, so we're going to leave this blank off plate on. But here is what that adapter would look like. It's really heavy duty foam. If you notice, there's no longer any oval shaped duct that we have to try to fashion up. It gives you that adapter to the round size. So here's how it drains out. We even have a way to clean out the drain just because gunk may collect in this little pocket right here. This screw is accessible from the filter access door, and you can kind of lift up this panel here or even remove it, and then you have access to clean out the catch basin of our drain. We have two drain bungs here. We have one for your main drain. I just screwed that fitting in there because I had a drain tube so it wouldn't drain all over my garage. And then we have an upper one here. If you notice this one's slightly higher, that's where you can hook up a float switch. Word to the wise, there is a plastic piece that you have to knock out in order for this drain connection to actually be open to the catch basin. So if you just screw a float switch on here without punching through that with like a screwdriver and a hammer, then it's never going to read any water. So maybe that's something that will be properly labeled on the actual production units, because nobody reads a manual, and a lot of installers, I'm sure, are just going to screw that on there, hook up a float switch, and that float switch isn't going to be doing anything. So always RTFM, but because you don't, I imagine they're probably going to put a label here on the actual production units to remind you. Let's move over to the control display. Here we have the similar display that we're used to seeing from these models. We have not only the ability to control from an internal sensor and then set our set point anywhere between 40 and 60%, but then we also have the ability to use an external sensor, and that would wire in this terminal block right here. After you wire it up, that snaps back in place with the pins aligning. We have the ability to run the fan on all the time, and if you're using this for a ventilating dehumidifier, that's what you want to do. Or you can have the fan just come on when we need to dehumidify. And that's obviously an on-off switch. These LEDs will flash fault codes if they see something going on, and then you can look those fault codes up in the manual. Let's talk about the refrigeration cycle. Just like any dehumidifier out there, this one is going to have obviously a refrigerant compressor. This is R454B. We're going to have a fan that pulls air through the evaporator and the condenser. Obviously, we're going to have an evaporator coil that's going to pull the moisture out. And then we've got to have a condenser coil, which also acts as a reheat coil. Now, it may only seem that we have two coils, an evaporator and a condenser in this model, but we actually have 5 coils, and I'm going to go through them right now. The first coil is what I would consider a pre-cooler. This is doing the sensible work. This is bringing the temperature of the air down to the point where it's really close to dew point, because unfortunately, for us to be able to pull out any of the moisture out of the air, we first have to do the sensible work and cool the air and bring the air temperature down to its dew point. But once we do that, we've got a second coil that's right behind us. Now that is this multi-row coil here. This is going to do the latent work. Typically, really good latent removing coils are going to have multiple rows because we have really good dwell time of the air across that cold coil. So we have a microchannel coil here that is sort of like your pre-cooler that gets you down to dew point. Then this multi-row coil is going to do the latent work. But there's actually another coil stacked behind it, and it's behind this plate right here. That coil recovers some of the sensible energy back, and that's what makes this so energy efficient. Well, the next thing that we get to is our condenser coil, also acting as a reheat coil. And this is a double condenser, but if you notice here that the condenser is actually taller than the rest of the coils that are in front of it. That allows us to pull bypass air. Normally there'll be a metal plate here. This is a prototype model, early release, so it's got tape on there for testing. But there'll be a metal plate here which will block some of the air from going through these coils, and some of that air will go straight through the condenser coil. This allows the impeller for the blower motor to pull some air uninhibited and put it straight through this coil. This makes it a little bit more energy efficient and increases the airflow a little bit. So again, we've got a pre-cooler, then we've got our actual dehumidification coil, then we have a recovery coil, and then we've got our condenser and reheat coils here. So that's 5 coils. Our liquid line comes out of our condenser and it goes through what I believe is a little filter dryer, a little torpedo dryer, and then we've got a cap tube. This is our expansion device. This brings us to our first coil. Now this is the pre-cooling coil. Once it passes through this header, then we go into our actual dehumidification coil. So really we can think about these coils as one big coil. Instead of making just a giant dehumidifier, we've actually separated these coils and stacked them one behind the other to save some space. So we go through our humidification coil, but then we're pulling off some of these bends right here, and we're then sending it into the next coil through this little cap tube here. We're bringing it into the next coil. This is the recovery coil, which recovers some of that energy. But if you notice, this header right here is tapping off of our dehumidification coil. So yes, we are pulling some gas out of it to the recovery coil, but the majority of that refrigerant is being collected here, and this is our suction line going to our compressor. Coming out of our compressor, of course, we're going to go into our condenser coil. We're going to go through that, reject the heat, provide some reheat. Coming out of here, this is our liquid line, and then we start the refrigeration cycle all over again. So it isn't that complicated. We can just think of an evaporator coil that could be really, really big, but instead they folded it 3 times. So there are 3 layers of that evaporator coil, and each layer does something different. We have a pre-cooling layer, which gets the air temperature down to dew point. Then once it's a dew point, we have a dehumidification coil, which does all the heavy work. And then we have a recovery coil. And then we just simply have a condensing coil, which also acts as a reheat coil. This is pretty much just one coil. It's just been folded in half. So this technology, having 5 coils, makes this super efficient, and it also allows it to be compact in size. Now, because we have 5 coils that are just stacked one behind the other, you need a heck of a blower to pull air through all of that. And notice the heavy duty plug style fan here. This thing really can move some air. Now we can discharge air out the end, or we can also discharge air off the top just by flipping that access panel off. For this particular installation, we're going to be discharging off the top because we have some space constraints. Here's the electrical section. I think it only takes a 15 amp circuit, 115 volts. We've got all the controls in here. We've got a power board. This is where a display is going to plug into. We've also got a number of sensors in here. They're going to talk to the display. The display actually is very robust in telling you what faults the system has. There are some internal faults to look at, especially if there's any refrigeration problems. We have temperature and pressure sensors in here that'll shut this thing down and alert you there's a problem if that comes up. Hopefully there won't be though. Now let's talk about some of the sensors that I've installed. I want to be able to just monitor the temperature and humidity and other data points here. This is the Shelly +1 models. These are Wi-Fi smart switches and smart monitors. You can do a lot with them. I've got a temperature and humidity sensor on 2 of these, so 1 of each. And then on the 3rd module, I'm able to hook up 3 pipe temperature sensors on there so I can monitor some of my refrigeration line temperatures. So let's go ahead and turn it on. Obviously, this display would normally be mounted to the dehumidifier. There is a spot for it, and you just have a couple screws that holds it in place. But let's go ahead and turn it on. And what we can do is advance our internal sensor set point by hitting this button. So we can select anywhere between 40 and 60, or we can tell to look for its external terminal block sensor that we've connected. We're going to go ahead and set it to 40 just so it'll stay running. We can also select whether we want our fan to run all the time or just when we have a call for dehumidification. Here's that really powerful blower that I was telling you about. This thing is an absolute beast. So I got to be really careful not to get my hands caught up in it because I'm pretty sure I'm going to pull back a nub if I do. But this is the kind of blower that is required to pull air through 5 coils. Obviously, we're bypassing the 3 coils a little bit as we pull air through our condenser reheat coil, but this is an extremely powerful blower. It's got a lot of horsepower, and it's also able to overcome a lot of duct static. So we don't have any problem hooking this up to normal static pressure on a duct system that maybe has 0.5 inches total static pressure. We can tap into the return, tap into the supply duct, and this fan is powerful enough to overcome that static and actually do the work that we're asking it to do. All in all, this is an amazing unit. It used to be that a 155 pint dehumidifier was about the size of a typical heat pump fan coil air handler. But now this is taking up the footprint of like what the old Ultra 98 dehumidifiers would take up. So it's a great choice. It's really not that heavy either. I mean, obviously 2 people need to pick it up, but it is not as heavy as you would think it is with all this dense coil and other parts and pieces in here. So I am really excited to put this thing back together and share with you some of the performance as we watch this thing in action in the commercial building that it's going in. Well, I hope you were as impressed as I was about all the technology that goes into making these new line of dehumidifiers so energy efficient and just what makes them so high quality. Santa Fe comes with a 5-year unit replacement warranty, and on year 6, they will ship out the faulty part covered under the warranty. That is unprecedented. Now, this unit is going to go into a commercial building, and it's time for me to go install it. See you next time. Here it is installed. It is connected to a 5-ton package unit. The supply is connected to the supply, and we've ran a dedicated return to the space. Now, I gotta also tell you, this unit is incredibly quiet. I don't know whether my microphone is picking it up good enough, but you can hardly hear the dehumidifier running. I don't even hear the compressor. I only hear the whirl of the blower. And on the other side of this wall is the occupied space, and you don't even know this unit is here. A great job by Santa Fe making it not only efficient, but also quiet.